Bismillahirrahmanirrahim. In this short video, we'll be discussing DC test of induction motor, and primarily we'll solve end chapter problem 7.1. Now, what is DC test? Let's understand. You know, this is stator winding, this is rotor winding. The equivalent circuit is something like this. This side is the rotor side, and this is stator side. This is stator resistance, this is rotor resistance. Okay, the rotor resistance R2, this R2 plays a very important role, extremely critical role in operation of an induction motor. It determines the shape of the torque speed curve. So this is important and we should try to know this value. But there is no direct method of finding this value. So we'll adopt a technique by which we find the total resistance. Now this is a standard motor test called locked rotor test, can be used to determine the total motor circuit resistance. So after we have found the total resistance, and we can calculate R1, for which there is a very simple technique. So the R2 can be found by total resistance minus R1. To find the rotor resistance R2 accurately, it is necessary to know R1 so that it can be subtracted from the total to find R2. Okay, there are two connections, Y connection and delta connection of the stator winding. The circuit, here we provide a variable DC voltage source. There is a current limiting resistor. And what we do is that we adjust the variable DC source. So the current through the ammeter is the rated current for this stator winding. And once the rated current has been achieved, we measure this voltage V. So to perform the test, the current in the stator winding is adjusted to the rated value and the voltage between the terminal is measured. And after that, we'll just use the simple technique V over I to find the total resistance. And from there, then we can find the individual resistances. So let's see the question. A DC test is performed on a 460 volt delta connected 100 HP induction motor. VDC 24 volt, IDC is 80 ampere. What is the stator resistance R1? And why is this so? First of all, since it's a delta connector, so we'll take this circuit. We plug in the values of the voltage and currents. And now we'll be solving this. You can see this will have to find the equivalent resistance. Now you can see these two are in series. So we'll draw another circuit. These two are in series in parallel with the R1. Solving this is the total resistance. So the equivalent circuit would look like this, and now we can easily find the from this relation V over I is equal to R. V is 24, I 80, and this is R, 2R1 over 3. And solving this, we can find the value of R1 to be 0.45. Now the question says why it is so. I don't understand what is expected. However, for delta connection, the resistance R1 is 0.45, and if you solve it for Y connection, I guess it will be 0.5 ohm. So I hope you have been able to follow this. Thank you.